In this video, we are going to evaluate the limit of a function when we are given the graph of this function. Now, when we write x approaches a or x tends to a, graphically we can think as x moving on the real line towards the value of a. So when we say that x approaches a, think of x as moving closer and closer to a and changing values. So for example, here we go. If I change the value of x, it approaches a. Could approach a also from this side. So when x is larger than a, we say that x is approaching a from the right. So this would be approaching a from the right. Remember that we're never going to be actually equal to a. So we're going to get closer and closer to a, but never equal to a. And if we approach a from the left, it would be like this. So we can approach a, as we saw, coming from the right. So that's when the values of x are strictly larger than a. And we can also approach a coming from the left. So that's when the values of x are strictly less than a. Now here's a function. It is actually the function f of x equals x squared plus 1. However, it is undefined at x equals 1. Hence, you will notice that there is an empty dot at 1, 2. We will investigate what the limit of this function is as x approaches 1. What is important to notice is that as x approaches 1, x varies, and so does the function value f of x. Here's a GeoGebra applet. You will be introduced more thoroughly to GeoGebra in the next video. It represents the graph of f of x equals x squared plus 1, and the function is undefined at x equals 1. As you can see, there is an empty dot here. What I wanted to do is show you how we can evaluate the limit of a function as we approach a given point. In this case, we will look at what happens if we are approaching 1. And I want to show you a graphical approach to this. Now, the slide bar here allows me to change the value of x. As we vary x, we will vary the point x, f of x, which belongs to the graph of the function. So if I change x, this point here is changing as well, because its coordinates are x, f of x. So px here represents the x value, and py is the function value at x. So py is equal to f of x. Now, the limit will exist if, as we approach a, this point approaches a specific point. And similarly, the limit will exist if the function values will approach a specific value. So let's see what happens here. So okay, as we approach a here, let's say coming from the right, so I'm looking at larger values, at values of x that are larger than a, than 1 here. As we approach 1 coming from the right, the point xf of x is approaching the point 1, 2. And the function values here are approaching the value 2. So 2 is actually the value of the limit as we approach 1. Let's check that it also works coming from the left, but it does. So coming from the left, the same thing happens. This point is approaching this point, and this function value is approaching the value 2. So we should always do this in our head, okay, when we're given the graph of a function and we want to evaluate the limit. Try changing the value of x, coming from the right, coming from the left, and seeing if as you move along the curve, you are approaching a specific point. What you should remember from the applet is that as x approaches a, we generate points x f of x that lie on the graph of the function. Or we could also say that as x changes value, the point x f of x moves and traces points on the curve y equals f of x. The limit of f of x equals L as x approaches a if those points x f of x are getting close to a point AL. In the previous applet, a was 1 and L was 2. But this point may not be on the graph of f, since f might not be defined at x equals a. We had this in our previous example, since f was not defined at x equals 1. The other thing that we can observe are that the function values f of x will approach L if the limit exists. In the previous applet, the function values on the y-axis were approaching 2. Here's the graph of another function. Notice that it is continuous everywhere except at x equals minus 2 and x equals 1. At minus 2 there is a jump in the function. The function value at minus 2 is 2, since there is a full dot at minus 2, 2, right there. At x equals 1, the function value is 1, since there is a full dot at 1, 1. And notice that at the other places, we have empty dots. Try to look at the 3 given limits and see if you can come up with the answers. If you look at the first limit, for example, what you should do is see if, as x approaches 4, the points x f of x trace points on the graph of f that are approaching a specific point. Now, pause the video, evaluate the limits, and unpause to get the answers. Let's take a look at the first limit. Now, as x approaches 4, as we move along the curve, coming from the right or coming from the left, we are approaching the point 4, 0, and the function values are approaching 0, which is the value of the limit. In the second limit, as x approaches 1, remember that x is actually never equal to 1 as it approaches 1. So the fact that f of 1 is 1 has no influence whatsoever on the value of the limit. So that full dot could be here, 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 down here. Whatever it would be, it would have no influence on the value of the limit. So if the limit exists, it is not influenced at all by the function value at 1. So we shouldn't be looking at that empty dot, that full dot, to evaluate or decide whether the limit exists or not. Now, again, as we move along the curve, coming from the right or coming from the left, we are getting close to the point 1, 2. Now, 2 is not the function value at 1, but it is the value of the limit. Because again, the function values as we approach 1 are getting close to 2. And 2 is the value of the limit for the second limit. For the third limit, if we approach minus 2 coming from the left, we are getting close to the point minus 2, 1. If we approach minus 2 coming from the right, we are getting close to the point minus 2, 2. So that means that coming from the left, the function values are getting close to 1, where coming from the right, the function values are getting close to 2. And because those two numbers, 1 and 2, are not the same, in this case, the value of the limit does not exist. So here are more detailed answers. So the first one is 0, the second one is 2. And again, we should not be influenced by the fact that f of 1 is 1 to get the answer of the limit. It has no influence on the value of the limit. And the limit is 2 in this case. In the third limit, the limit does not exist because there's a jump in the function at minus 2.